Imagine we have 10 airtight boxes, each hiding the strangest forms of matter in the universe. Today, we're bringing them to Earth and opening them one by one to see if our planet can handle the strain. Some will simply vanish, while others could wipe your city off the face of the Earth in a split second. We're starting our experiment. Rule number 1, don't breathe in the contents, especially if the contents don't want to be breathed in. Container number 1, interstellar gas, the emptiest thing you've ever held in your hands. In space, this is ultra-diluted hydrogen and helium, 1 atom per cubic centimeter. On Earth, under our pressure and temperature, this container will seem absolutely empty. To collect even a single gram of this gas, we'd have to vacuum an area the size of the moon. As soon as you open it in your room, Earth's air will rush inside instantly. Pop. It's safe, but incredibly disappointing. You just spent millions of dollars transporting a vacuum. But what if we take something more tangible? For example, interplanetary dust, container number 2. This isn't the dust under your couch. These are remnants of comets and asteroid collisions. It's microscopic, but incredibly sharp. Cosmic erosion turns it into tiny, jagged blades. When you bring it to Earth, you'll notice something strange. It sticks to everything because of its static charge. In our humid atmosphere, that charge will dissipate quickly, and the dust will just become mud. Plain old space mud. But be careful. Inhaling this dust can cause microcuts in your lungs. Real space flu. It has to be kept in a vacuum chamber, or Earth's moisture will oxidize the rare minerals inside. But that's just the beginning. Up next, the legendary lunar regolith. Container number 3. Apollo astronauts said it smells like spent gunpowder. On Earth, that smell fades quickly as oxygen reacts with the particles. Moon dust is a total nightmare for technology. It's abrasive and destroys any joints or mechanisms. If you spill it in the lab, you'll have to call a hazmat team. It gets everywhere. You can only keep it pristine in pure nitrogen. Without it, the dust loses its chemical bite.
But wait, we've only just begun. Soon we'll get to ice that burns and metal that behaves like a liquid. Container number 4, exotic ices. And no, this isn't what you put in Coke. In space, ice isn't just water. This is frozen methane, ammonia, and nitrogen. Bringing them to Earth would be like creating a chemical time bomb. As soon as the temperature rises above minus 160 degrees, the methane will begin to turn into gas. If you stand next to an open container, you'll simply suffocate or explode. There are also clathrates, caged ice, where gas molecules are trapped inside water ice. On Earth, such a thing would hiss and shoot gas until it completely melts. To preserve this treasure, you'd need a powerful cryostat and several atmospheres of pressure. The benefit? Enormous. This is the purest fuel, delivered straight from the depths of the ice giants. But we're moving on to something truly strange. Substance number 5, superfluid helium. This state of matter is almost never found in nature, except in the coldest corners of space. It has zero viscosity. If you pour it into a glass, it just comes out. It flows up the walls, defying gravity, seeking a warmer place. On Earth, containing it is a task for a genius. Any microscopic crack, and it's gone. Its thermal conductivity is infinite. It cools instantly and evenly throughout its volume. This substance is the key to the quantum computers of the future, but it hates Earth's heat. Have you ever wondered if you can touch the solar wind? Number 6 is plasma. It's the 4th state of matter, an ionized gas that obeys only magnets. On Earth, plasma lives in lightning and neon lamps, but space plasma is something else. Bringing it in a jar will only lead to a problem. It wants to expand and burn up your jar. Without a magnetic field, it will instantly touch the container's walls, cool, and turn into ordinary gas. To store it, you need a magnetic trap, invisible walls of magnetic fields. Space plasma carries colossal energy, but on Earth, it's a capricious guest. We've passed the equator. Ahead lie fragments of fallen stars and metal that can't be sawed. Number 7, meteoric iron nickel, the only honest guest from space. Unlike gases, this piece of metal can sit on your table for billions of years. If you cut it and etch it with acid, you'll see Widmanstätten patterns. These crystal patterns grow over millions of years as the asteroid slowly cools in the void. Such conditions are impossible to create on Earth. It's a natural passport from deep space. But there's a downside. Some meteorites contain inclusions of toxic gases or radioactive isotopes. So don't rush to use it as a weight for pickling cucumbers. These are complex hydrocarbons and tholins, a sticky, stinking brown mass from comets. It probably tastes like burnt rubber mixed with formaldehyde. Don't try it. If we bring this to Earth, we might find amino acids, the building blocks of life, in this mud. But Earth bacteria will eat this organic matter faster than you can say abiogenesis.
We need to keep this regolith in absolute isolation from our air. Ordinary nitrogen is a lunar geologist's best friend on Earth. It's inert and prevents the dust from oxidizing. If you decide to keep regolith as a souvenir on your shelf, it turns into a poison. Without a vacuum or nitrogen, the particles clump together, absorb moisture, and become chemically aggressive. But enough about dust. Next up, container number 4, exotic ices. In space, ice isn't just frozen water. It's methane, ammonia, and even nitrogen. On Earth, at our temperature, this ice doesn't melt. It explodes. Methane's boiling point is minus 161 degrees Celsius. Our room is like a scorching furnace to it. You bring this ice into the lab, and it instantly turns into thousands of liters of gas. If it's methane, a single spark will turn your building into a fireball. Ammonia ice is even funnier. As it evaporates, it eats through your lungs and eyes. But there's something even stranger, clothrates. It's an ice cage for gas. Water molecules create a frame that traps methane molecules inside. In space, they are stable. But on Earth, such a piece of ice will hiss and spit fire. These exotic ices must be kept in massive cryochambers under immense pressure. They are valuable fuel for future colonies. But on Earth, they are dangerous cargo. Ready for some quantum wonders? Container number 5, superfluid helium. In deep space, in the shadows of asteroids, matter can cool down to near absolute zero. At temperatures below 2 Kelvin, helium turns into a liquid with zero friction. If you pour it into a glass, it will simply crawl up the sides. It seeks any source of heat and moves toward it, ignoring gravity. It's impossible to hold on Earth. It will leak through the micropores of any container. Its thermal conductivity is perfect. If you heat one end, the entire volume cools instantly. This substance behaves not like a liquid, but like one giant quantum particle. To keep it, we need equipment worth millions of dollars. One clumsy move, the temperature rises, and the helium vanishes instantly. But if you thought that was weird, just wait. We're opening container number 6, plasma, solar wind in a jar. It's not just gas, it's electrified chaos. In space, plasma makes up 99% of visible matter. Stars, nebulae, comet tails. On Earth, it lives in lightning and neon lamps, but cosmic plasma is terrifyingly hot. By bringing it in a container, you'll find it wants to burn your container from the inside out. To keep it from touching the walls, we need powerful electromagnets. This is called a magnetic trap. If the power goes out, the plasma cools instantly. Boom! The energy is released, and instead of plasma, you have a pile of useless hot gas. Keeping it on Earth is like trying to hold a raging tiger in a cardboard box. We're only halfway through. Time for the heavy artillery. Number 7. Meteoric iron nickel. The only thing you can bring back without special effects. This is the heart of dead asteroids that once dreamed of becoming planets. On Earth, it's stable, but its structure is unique. Wittgenstein patterns. These patterns grow over millions of years as the metal slowly cools in a vacuum. It's impossible to replicate this in a lab. This piece of iron is the universe's original masterpiece. However, be careful. Alien isotopes often hide in such iron. They won't kill you instantly, but keeping such a souvenir under your pillow is a bad idea. But what if space brings us soot? Container number 8. Cosmic organics, tholins and complex hydrocarbons from the distant moons of Saturn. This isn't life, but it's the spare parts for it. Amino acids born in the void. On Earth, this mass smells like a mix of burnt meat and gasoline. It's very unpleasant. It's hard to preserve. Earth's bacteria love these treats. If you open the jar, terrestrial life will simply eat the cosmic organics in a matter of hours. We have to keep it in a sterile box, or the experiment to find life will fail. Have you ever wondered if we ourselves are made of this cosmic soot? But now is not the time for philosophy. We have 2 containers left, and they contain things that shouldn't exist on Earth at all. The 9th substance is an extreme pressure material, metallic hydrogen. Inside Jupiter, hydrogen is compressed so much it turns into a shiny metal. We don't have presses on Earth that can hold it in a stable state. If we bring it and the pressure drops, it will be the most powerful non-nuclear explosion. Ready to see what happens next? Because ahead of us is degenerate matter. Container 9. Here lies something scientists have tried to create for decades: metallic hydrogen. In normal conditions, hydrogen is a transparent gas, but in the depths of Jupiter, everything is different. There, the pressure is millions of times higher than ours. Molecules are squeezed so hard, they start conducting electricity. This substance is the holy grail of energy. Room temperature, superconductivity, and incredible energy density. But there is one small problem. As soon as you take it out from under the press, it will want to expand. If metallic hydrogen is metastable, it will remain a metal. If not, there will be an explosion. The energy of this expansion is 5 times more powerful than TNT. Your lab will turn into a crater. To keep it on Earth, we need diamond anvils, tiny vices made of the hardest stones. But even then, this substance is constantly trying to leak through the crystal lattice. It's the perfect rocket fuel. We could reach Mars in a matter of weeks on it. But to date, we've only obtained micrograms, and they cost as much as an aircraft carrier. Now imagine a substance that can't be held by any press at all. We've reached the finale. Container number 10. Degenerate, the matter of dead stars. In space, these are white dwarfs. Stars compressed to the size of Earth. Density beyond comprehension. 1 cubic centimeter of this soup on Earth would weigh about 10 tons. You can't just put it in a box. It will punch through your table, the floor, and the building's foundation. It will fall until it reaches the center of the Earth, melting everything in its path. But that's just the start of the problems. Outside a star's gravity, this matter is unstable. A white dwarf is held together by electron degeneracy pressure. On Earth, that pressure will vanish. An instant expansion will occur. It would be like a miniature supernova explosion. Your entire city will simply vaporize. Only radiation and a lot of questions will remain. But what if we go even further? Neutron stars, the densest objects in the universe. A teaspoon of neutron star matter weighs as much as Mount Everest, 1 billion tons. This spoon has such gravity that it will start sucking in the surrounding air and you. On Earth, neutron matter would instantly turn into pure energy. The explosion would be visible from the moon. Thus, bringing this home is physically impossible. You're not carrying a sample, you're carrying a death sentence for the planet. You can only store this inside another neutron star. Convenient, isn't it? We've opened all 10 boxes, and the result is mixed. Our planet survived, but I feel sorry for the lab. Have you noticed a strange pattern? The more exotic the substance, the less it wants to be on Earth. Our atmosphere and pressure are a very specific filter. Space is aggressive to us. But then again, we are part of this cosmos. We're just used to its very quiet corners. Using cosmic resources is always a struggle against the conditions in which they were created. Want to mine helium-3 on the moon? Get ready for endless abrasive dust in your robot's lungs. Dreaming of the energy of stars? First, learn to build magnetic cages that won't melt. Our experiment showed bringing space isn't just logistics. It's changing the rules of the game. Every substance requires its own world. And sometimes, these worlds are better off not being mixed in the same room. But what if we go to these substances ourselves? Without boxes and containers. This would require technology that turns our spacesuit into a mini-planet with its own pressure. And then we could touch a metallic hydrogen without fearing an explosion. Well, almost. We're returning to reality. But wait, I think I forgot to close one of the boxes. Do you hear that strange hum? The plasma container is starting to vibrate. The magnetic trap is failing. The sun's energy is breaking loose right here in our studio. 1 second. I think I found a way to fix this. I just need to turn off gravity. Oh, now everything is levitating. The regolith, the ice, and me. This is a bad idea. Interplanetary dust has gotten into the ventilation system. It's about to get very messy in here. The cosmic organics have started reacting with my tea. I think we've created new life. It looks cute, but it smells like burnt rubber. Space is very specific in its perfumery. Let's try to gather everything back before we're kicked out of this galaxy. We need more nitrogen and more vacuum pumps. Faster. Phew. Seems we've stabilized it, but the metallic hydrogen is still glowing suspiciously. The experiment is over, but the lessons remain. Space isn't a warehouse of raw materials. It's a different reality. Each of these substances is a key to a door we're only just learning to open. And maybe in the future, these 10 containers will become common items in our daily lives. But until then, keep your distance, especially from neutron stars. They don't like hugs. Thank you for traveling through these 10 weirdest forms of matter with me. Next time, we'll bring back something even stranger. For example, nothing. The vacuum of space is also a substance if you look at it from the right angle. But more on that later. Take care of your atmosphere. It's the only thing separating you from turning into plasma. Like this video if your regolith container is still airtight. And subscribe. And now, I'm off. It seems my piece of meteoric iron is trying to eat my breakfast.